Hey everyone, so my name is Zach Vines, and today we're going to go over some of the most important variables to know in statistics. So much of what statistics has to do with is just formulas, plugging into various formulas. Yes, it's important to know what they accomplish and what the point of the formula is, but one of the challenges that I've seen many students that I tutor encounter is not knowing what those numbers are. Like for instance, we might have a formula called x bar minus mu divided by s divided by square root of n. And we'll get a lot into that in later videos, but the important thing to know is what is x bar, what is mu, what is s, what is n. You need to know those things in order to be able to solve the formula, obviously, and you need to be able to pick those things out of the problems because they oftentimes don't tell you n is this, x bar is this. You actually have to denote that from the problem and figuring it out on your own. So we're just going to go over some of the main variables that you're going to see in statistics problems. So by the time you run into those formulas, you can pick them up and it's no problem at all. So the first one is going to be the number in the sample. That is just n. So one important thing in statistics to note is that we don't always want to run information on every single item in a population. So an example I always use with the students that I tutor is, let's say I wanted to find out the mean height, the average height of students at my university. Well, it's going to be a bit of a pain and it's going to cost a lot of time. It's going to take a lot of time, cost a lot of money in order to sample every single person at my university. Get them lined up, go, how tall are you? Okay, write that down. How tall are you? Write that down. And do it over and over and over again. So the point is, we're going to go take a sample out of that population, run some information on it, and then make an inference about the population based on the sample. So let's keep that same example. I want to find the average height of students at my university, and I sample 200 students. N is going to equal 200 in that case, okay? So that's one of the most basic variables to know. Simply, you take a sample out of a population, the number of whatever it is that you're sampling, it could be anything based on what problem you have, that's going to be n, the number in the sample. So kind of going off of that, if I'm trying to find the mean height of students at my university, x bar is going to be the mean of that sample that I took. It's really important to denote the difference between the mean of the sample versus the mean of the population, which is actually going to be mu right here, mu. It looks like a little funky u, because the sample is a subset of the population. You take that sample, you add up all the values in that sample, divide by the number in the sample, and that's going to give you the mean of that sample. Now, you can make inferences based on that sample value, off that sample mean, to the population, but oftentimes they're going to be a little bit different. The point in statistics when you sample something is for it to be as representative as possible of the population as a whole so that you can make the proper inferences. Because if you take an improper sample, then it's not going to carry over to the population very well. So when we're dealing with this problem, for instance, let's say the mean in my sample of the mean height of students in my university is 5'7", but in actuality, it might be 5'8". The problems will often tell you which one is from the sample and which one is from the population, so just make sure you do that accordingly. So x bar, mean of sample, mu, mean of the population. The next thing we're going to do is the proportions. So just like how we can do x bar minus mu divided by s divided by square root of n, you're going to see a few problems where instead of us wondering about a mean value, like me wondering about the average height of students at my university, I may be wondering a part out of a whole, a proportion that I'm interested in. So if I want to find the proportion of the sample, what I'm going to do is take that sample, and if I'm interested in the people who are over 5'8", let's say, then I'm going to find the people who are above 5'8". So this is going to be, okay, so the number we are interested in divided by n, just the number in the sample, right? So let's say I sample 200 people, and let's just say 150 of them end up being above 5'8", because that's the number we're interested in. We're wondering how many people are 5'8" or taller. Then that's going to end up being 0.75. It's a proportion, so it's a part out of a whole, and it's always going to be a number between 0 and 1, because 1 would be 100%, 0 would be 0. So that's how the proportions work, and so that would be in my sample, but again, just like how there's going to be a difference between the sample mean of the the mean of the sample versus the mean of the population, there's oftentimes going to be a difference between what your sample says and what your population says. So pi right here is the proportion of the population as a whole, while f is the proportion of just the sample you took. And here's an example of a way that you would find that. So those are important variables there. Finally, the last two that we'll go over is just standard deviation. Oftentimes in problems that we get, it's just going to directly tell us what the standard deviation is, but it's important to know what that variable is, so when you have to plug it into a formula, you know what S is, because oftentimes your teacher's just going to give you the formula, and that's what you do to find a test statistic or many different variables in statistics. And so you just need to know that S is the standard deviation. And then finally, this is called sigma right here. It's like a little circle with a funky hat on top of it is the way I think about it. And that's just simply the standard deviation of the population. So you'll see over time that, and this is where a lot of students get confused, is that for the same type of value, so for a mean or a proportion, there are sample variables and there are population variables. So it's really important to denote the difference between the two, because by the time you have to plug them into a problem, it's going to affect everything if you plug in the sample for the population and vice versa. So I would say those are the main variables to know about. There's going to be plenty more as you get further down the line in your studies and further down the line into some more nitty-gritty, nuanced problems. But I would say that these are the main ones to know, and if you can have those down, you're definitely in good standing to start.